What's up, guys? And today we're in another video. This video is about the basics of coordination chemistry, and this is tied into what types of ligands occur, what types of ligands exist in coordination chemistry. So this topic consists of three ligands that we normally refer to in inorganic chemistry, and this is based on the CBC method, the covalent bond classification method, which is helpful in describing inorganic chemistry structures. So in this video, we're going to learn about the three types of ligands you can find in this CBC method. So first off, we have the X-type ligand. The X-type ligand, as I defined here below, is the type of ligand which donates a single electron to a metal center to form a traditional covalent bond. So what we mean by this is to form a covalent bond, one electron will be donated by the ligand, whilst the remaining electron will be donated by the metal to form that covalent bond, usually a sigma bond in these in molecule formation for this particular type of ligand. There's also the L-type ligand. The L-type ligand donates a lone pair of electrons to the metal center, as opposed to the X-type ligand. The X-type ligand only donates a single electron. This donates two electrons directly to the metal center to form a dative covalent bond or a coordinate covalent bond. And we have the examples of carbon monoxide playing the role as an L-type ligand in inorganic chemistry. There's also trimethylamine and triphosphoramine. So specifically, these are ligands. These are L-type ligands because they each donate a lone pair of electrons. So the lone pair is directly donated to a metal center. Let's say M is the metal center. This is the example of trimethylamine. It's an example because it has a lone pair. So this is an L ligand. And then this is trimethylphosphine because it has a lone pair and it's an L-type ligand. Then we come to the example of Z-type ligands. Z-type ligands can be seen as the opposite of L-type ligands. These ones are not as common compared to X and L, but let's go through it. So this is the type of ligand which accepts a lone pair of electrons from the metal center to form a dative covalent bond or to form a coordinate covalent bond. And in this sense, the ligand is actually acting as a Lewis acid because a Lewis acid is an electron pair acceptor. That's what we know from acid-base chemistry. And so we have the examples of boron. And so in this case, the metal would be donating a lone pair of electrons directly to this boron compound. And that is because in this boron compound there's an empty atomic orbital which can easily be filled up by the electrons being donated by this metal. That's why it acts as a Lewis acid. The same thing with Br3. This metal donates a lone pair of electrons, and usually we depict this as an arrow when a lone pair is being donated to an element or an atom in inorganic chemistry, as opposed to as opposed to like simple bonds. Simple bonds like this can represent sigma covalent bonds. They can also they mostly represent sigma covalent bonds, but when you see an arrow, that means that a lone pair of electrons is being transferred. You can also represent that the same way here, so that you can be a little more specific. So in this case, the lone pair from the carbon is being donated directly to the metal, and so that would be correct. But in this case, the metal is directly donating a pair of electrons to the boron. Sure, hope that makes sense. Please, like as always, comment in the comment section anything you want me to go through in specifics. If you want to see more examples, and I'll see you on the other side. Thank you very much.